Okay, we're booting this back up for a little bit. Meeting got pushed, but I want to get this done. So, right. I think the only way to do this is going to be to, so right here, so forward. Now I have to come up with some data for this. So let's just do data equal, it's kind of awkward data, isn't it, as well? Porch.arange. It's 10 agents times 11 times 11 times 4 plus 26, I believe, with the parems like this. %16. And then we reshape it like this. No, it doesn't get reshaped. It just is flat, right? And then we do the state as well. Let's start with this. I want to get this done today. Invalid input tensor. Really? That is because I'm dumb. Float, I believe. Yeah, it's a float. You do like this. Input type, right. Map device CPU. Welcome, YouTube folks. Schedule's getting all chopped up today with stuff I gotta do, but I figure we'll try to get this done right now. Okay, so output is multiple. They're the actions, right? And we can see that we get these as outputs. I think I need to print out. I think I need to print out at every layer, don't I? Yeah. I need to print out stuff at every layer. Oops. Obit.c. Okay, so in the forward pass here, we just have to print some stuff, right? So first we gotta print obs2d. %f /n, and then we do obs2d 0 0 0 0, which really we should just, yeah, we can do like this, obs1d, and then what we do is print output 0. Yeah, this is what we want. We just want to check the first element of everything. That's not a foolproof check, but like, that should get us most of the way, I would imagine. And then we have to exit here. So we have to like, there's no exit function, right? Assert 0, that'll crash it. Yeah, there we go. So now, wait, we also have to do, we have to give it the fake data, don't we? Step env, yeah, so we have to do I less than num agents times 11 times 4. And then what we do is env observations map of I. We have to set it to the same dummy data, I%16, right? Yeah. Ooh, that's kind of gross though, isn't it? Because you don't have any way of taking into account the flat data like this, do you? Well, that's awkward. How am I going to do this? Shoot, yeah, that's really awkward. Because I have two separate observations here, right? Come on, there's got to be a smart way of doing this now. I think you'd think so, but you'd be wrong. Plus 26. Can I just do like if %? No, I'm gonna get, if I do it this way, I'm gonna get the data wrong, and then I'm gonna spend forever debugging the stupid data. Like, I'm gonna be debugging the test. Okay, here's an idea. I can do the first row. Dot. Well, let's try this. Okay, that gives me something. And now all I need to do is I replicate that here. It's basically already done. Data of 11 times. Okay, let's try this. Oh, this doesn't work. That's really rough as well. It's like, how am I supposed to debug through something of this size? Really obnoxious as well that I decided to save the network in the way that I did, alright? Okay, so we're gonna print. Actually, that 2D observation is, yeah. So what we're gonna do is print CNN features. For map features. Let's see what this looks like. Okay, so observations 2D is correct. Observations 1D is different. So already we have a discrepancy. Why is there already a discrepancy? Probably because... No? Oh, why did this go to 256? Freaking autocomplete, man. Okay, so now look at the data. The data is correct here. And then we get out of conv. The conv is wrong, though. Okay, so why is the conv wrong? Is the data going into the conv correct? It's kind of tricky. Okay. Can I do like 19, 11, 11? So wait, 1, 1? This should be 1, right? If I'm right. No. Okay, why is that not 1? Oh, because this is... It should be like this, maybe? No. Very confused. Wait, channel. Let's just do obs and obs 2D. Alright, let's just do it this way, you know? Double, got unsigned char. Okay, that doesn't work. Wait, env obs. This should be net obs 2D. And this should just be fi like this. Okay, so what does this say? One. Does that match? Okay. We do the PyTorch version again. Dot shape -1 dot 10. It should be good. It should be it, right? And then we run this one. Okay. So this looks good, right? This 2D data matches. Does this 2D data make any sense? I don't know if it makes any sense, but it says it is. Then CNN features, it says is wrong. Okay. Well, we're not going to let that stop us now, are we? Comp 1 features. And then we're just going to do self.cn. Zero. CNN features. How about this? Expected. Okay. drive me nuts here. Let me also reply to one thing real quick. I forgot, I got a DM on a thing. Cool. Dot shape. Okay, this is not what I expected it to be. This should be that's all. This has to go there. Conv1 features. Conv1 features. Well, we got the data. And it's like interestingly close, but still too far off. The observation is small enough that I can check all of the data, though. That's the key. If I'm just doing one observation, I can check the entire data. I should make use of that luxury. Map features. So let's do map features of 0 like this. And then CNN features. Let's do of 0 like this, maybe. Okay. And then we'll do, hold on. Yeah, we're not going to leave any of this to chance. We're going to make sure all the data is exactly the same. That's how we'll have to do it. So this is going to be 11 times 11 times 4. Yeah, we're going to have to... That's so obnoxious the way that this is. I think we leave it like this. And then we'll just do... Yeah, we'll just do like this. Printf obs2d space printf/n. Okay, so now we can see our data correctly here. And we're going to do the exact same thing for conv1 output, which is going to be a lot. So we're going to do printf conv1, printf 7/n. And then this is going to be a ton of data, but this should tell us pretty much instantly what we screwed up here. So here we have our observations, right? This is so close. This is like actually so close. But that's too big of an error for like numerical precision, right? Yeah. It's possible that I have the bias term wrong in my con. That would do it, right? I thought I tested that, though. Thought I tested that. How did I test conv? So if I test puffernet, it passes, right? What if I 10x the bias term? Still passes. So according to this, the comms are correct. According to this, the conv is correct. So that leaves that I have the data in the test wrong, or the input is wrong. Observations 2D. U.numpy.toList. Try this. So I can see exactly. Which should give me, yep, massive list. I don't know why they're actually like this if I think about it. But, 1, 2, 3, 1, 1, 2, 3. Yeah, the pattern is pretty consistent. It's probably a bad pattern, actually, now that I'm thinking about that, because, well, I guess it's going to be sparse regardless. It's a one hot. This goes on for a long time, though. Wait a second. Look, no. This is not... I have ones down here. This is all zeros. Okay, the memory format's different then, right? CNN features is 19. Size 19, right? No, it should still print them in the same format regardless. Yeah, you can see here. Memory loud is totally different. And it looks like there's actually way more stuff in here, isn't there? Hang on. Let's do that's 0.sum. Yeah, that's actually a good point here that there aren't any. You can see that there should be extra data at the bottom here, right? Be all sorts of extra data. Let's see what's in the MOBA. OBS 2D. Network. Well, I just am not printing enough of it here. Right, this is supposed to be 19. And then we run it. Okay, there we go. 118. The data is different down there though as well. Look, I can see that the end of this is not the same. And what about the start of it? If this is contiguous, I should be able to see. Oh, wait, hold on. Down here? Yeah, data format's totally different, right? Maybe not. Hold on. CNN features 0. CPU.numpy 2 list. Okay, so we have here dense data at the bottom. Did you restart stream? Yeah, I took a little break to do stuff. Actually, I gotta do I have a meeting again in like 28 minutes or whatever. I hate having to break up the streams like this, but it's gonna be what it's gonna be. I mean, we can clearly see that the data is off here. The format of it. because like I have here dense data at the end. I get dense data at the end, right? And then I don't have dense data here at the end. It's very weird. Let me just make sure one thing. Yeah, so you can see I don't have dense data when I ravel as well. Okay, so let me think about how that is the case. It should be dense, right? The dimensions are batch, channels, row, and col. So when you go to the channel should be stored major. Yeah, after batch, it's channels major. So why wouldn't that be the case in my my thing? It's got to be my preprocess, right? We know my conv is good. How's it stored in memory? So we can see here it's stored in memory in this format, right? YX, the last one. Am I just wrong here? I think I'm just wrong here. Isn't this like +1, +2, +3? Isn't this it, right? Like this? Oops. Yeah, there we go. And then it's still not the same data though. Oh, is it all dense now? Oh, wait. No, here it is. Matches. And then what's the first thing in this big chunk? We get 039, 019. Yeah, there it goes. And then how about at the top? Like, is this, we get all these ones with blocks of zeros. Looks good. So let's see, if I do this, then we look at the conv. Conv is still not good. CNN features. About the start. Oh wait, we do have the start of the conv is good. And then by the end somehow it's not. But maybe I just have the dimensions wrong. Hold on. Maybe I just have the dimensions wrong. Okay. 11 times 11 times 19. Well, yeah, that's freaking wrong. I'm dumb. I believe it's 3 by 3 by 19, isn't it? We should probably just check. Did I mess up? I messed up here. CNN features. Oops, CNN features. 0 dot shape. Well, just dot shape. 10, 32, 3, and 3. So 32 by 3 by 3, which is correct. That's 32 channels, and then 3 by 3 window, which is what it's been reduced to from 11 by 11. I love how you keep pushing it for me. I question my insanity. Basis of how things work. Well, yeah, I did that for many years, right? But then the thing is, like, I've been working in this space since I was 16. So, like, at some point you realize, like, you learn enough that maybe I don't know everything here, but, like, I know when I don't know something, right? So it's very rare that I'm making some error because I'm, like, fundamentally missing something basic, right? It's very, very rare. So what I have is I basically have the ability to confidently make progress on anything in this space without, like, worrying that I'm missing something super dumb. Believe me, I absolutely, when I started, I would have like multi-day bugs, multi-week bugs. It was god awful. But now, like, I can pretty consistently just clip away and make progress at stuff. Took a decade, but I got there. Okay. More than a decade, really. Ah, look at this. Speaking of clipping away and making progress, that matches. That matches perfectly. And would you look at that? It matches all the way to the end of the CompNet. So let's see what we're doing now. But mind you, the reason we had this bug was because of this one-off pre-processing function. So it's very short code, but it is obnoxious how easy it is to get stuff wrong. Okay, so let's do like this. CNN features. Okay, so now we have our CNN features here. I want to do, in a few places, I want to get everything. I think Kira is one of them. So we'll do the flat features, print flat features, like this. The other thing that is important I've found is, like, before it was so much worse programming when I couldn't make consistent progress. I will get bored very quickly with things if I'm making zero progress, or if things are just too slow. So doing stuff in a way that I can make consistent progress is very, very important, because otherwise I'll get bored and make zero progress. Like I can't force myself to focus on something when I'm just completely bored. It just doesn't work. So here I have like a pretty concrete thing to do. I know roughly how to do it. So this is where we put conv output. So this is CNN, conv2, and this is just 32 dimensions, I believe. Conv2 output, and then linear here for print the flat output. Oops. Where did we do this? Detach CPU numpy. Detach. Okay, so we have our features. There are not very many of them. What happened? Something got eaten here. I think just the label got eaten. But these are correct, and then 104. The flat features look wrong, which I would think is very weird. Hold on. Why would the flat features be wrong? No, the first ones are right, and then 03. Is this like 0.223? Something's weird here. Flat features dot shape. 10 by 32, right? Oh, because I did 10 by 26. Yeah, I stupid autocomplete. Yeah, that's fine. So let's just fix this. I'm almost positive that we're good now, but let's just check. It's gonna be so obnoxious having to change the network architecture, I will say, with this. But it's fine. We'll deal. I think I entered Alien language zone. How did I end up here? Keep going. It's not that bad. Like, you get used to it. It's very difficult for me to articulate exactly my thought process because, like, I'm doing memory addresses and stuff in my head. I'm here, like, I can teach you the memory address logic I'm doing in my head in all of, like, 10 seconds. It's literally just, like, you have a certain number of channels in your array, but you have to flat index. You only get one number to access it. So if you want, like, the last dimension, then it's going to be like the first dimension times the second dimension times the third dimension times the index plus the second dimension times the third dimension. Let me just grab the formula. I'll show you. It's not that hard. Here. There. It's just this. It's just like, you know, x times width plus y times depth. Yeah. It's just that. There you go. That's all I'm doing. And I'm just like thinking about the way that the memory is laid out and just making sure I'm actually accessing the data that I think I'm accessing. So nowhere near as bad as it looks. Perfect. So these match. So now all I have to do is check the yeah. Like you can see, but you can see my thought process, right? What I'm doing is just like I'm very painstakingly going through and like I have the exact same data on Python side, I have the exact same data on C side, and I'm just stepping through one layer at a time and I'm making sure that the operations exactly match each other. And probably eventually I'm going to add. I mean, this is the type of debugging that I do when I'm getting something to work in the first place. And then I have a different type of test that I'll write once I know something is working to prevent myself from breaking it again, right? So like this type of thing, it's very difficult to write a test for because like there's so many different places stuff can be wrong, and just knowing that the final output is wrong isn't that helpful. So I do this more interactive debugging, and then when I have a piece of code like this that's really finicky and I really don't want to break in the future, I'll write a test to make sure that the output is correct but not do anything else. So then if I ever introduce something that breaks the output, right, then I can run that and say, oh, okay, I broke it. And then I can go back until I didn't break it and see exactly what I did that broke it. So, nowhere near as bad as it looks. Less than, was it 128, I believe? So yeah, now we're going to look at this one here, which is pretty deep into the network at this point. We're going to get we're going to get it working quite soon at this rate. Though I have a meeting in a little bit here, so my hope is that we'll at least get this next layer or two checked. And there. Uh-oh. Bad syntax. Bad me. Okay, so why are these flat features of a weird dimension? Feature 0 dot detach. What? Did I go into stupid land or something? What's wrong here? Feature should be 128 dim, no? Oh, I just didn't run it long enough there. 7600047 862. Perfect. So all the way up until the LSTM, the network is correct. Isn't that lovely? Now the big one is the LSTM. LSTM, which is semi-obnoxious to test actually now that I think about it. Because that's in a gross wrapper, isn't it? Yeesh. Oh, actually, wait a second. I know how I can do it easy. Easy. We do... in decode actions, right? The flat hidden. I can just print it here. The thing that's going on there is that the LSTM is introduced by like a wrapper layer, but the LSTM output will be what goes into flat hidden. So this should be good. And we just do like this. And then we run it here. Flat hidden. Uh-oh. The LSTM is all 0. That's not good. But what did I print? I might have done something jank. Does LSTM even have an output like this? Wait. You know, when I finish this puffernet, you all are going to be able to play around with it. You can use puffernet to run stuff on the web if you'd like. So that's going to be cool. I get to do all the suffering, and you just get to enjoy it. Don't suffer. Use puffer. Oh, it does have an output, doesn't it? Wait, this literally does not have output. Yeah, this thing does not even use output. Okay. Well, that's a frickin' joke. Yeah, it's in place here. It just doesn't state. We better enjoy was hard work. Heck yeah. Friggin' takes a lot. I hope you're enjoying the puffer. Good puffer. What is it? Is it state H? Yeah, state H, state C. I think it's state H is what we want, right? Hidden state. What? No. I like how it just auto-completes random stuff. Great feature, 10 out of 10. Okay, so here's our LSTM. And I don't think that's right. Was it hidden or cell that we need? I don't know if it's hidden or cell. I do have a meeting to go to in a couple minutes here. But I will be back after said meeting to finish this, because we're getting very, very close. Oh, okay. I gotta get off, actually. See you all in a little bit. Bye.